Now, another reason why I like this is because at the end of the month, we're going to be doing ERBs. So a lot of these terms like composite and prime, factors, multiples, you may have forgotten. That's why I like this. All right, so review of all the terms that you should know. If you forgot, that's perfectly fine. That's why I'm doing it. All right, so here we go. Now, number one, a number is chosen at random from 1 to 10. Find the probability of selecting a 2 or greater. William? 9 over 10. All right. Now, he said 90%, I think, or 9 over 10, or 0.9. Does it really matter? No, but if you were paying attention to what I said last week, generally probability is what? A fraction. Generally, it's a fraction. Not always, but most of the time. All right. Now, he said, hold up, he said 9 out of 10. He said 9 out of 10. Does anybody have any complaints about why it's 9 out of 10? What? How many numbers from 1 to 10 are 2 or greater? 8. Why 8? Yeah, we got to read carefully, right? That's helpful. All right. It doesn't say greater than 2. It says what? 2 or greater. So you got to be careful. All right. A number is chosen from random from 1 to 25. Find the probability. I don't like this. Find the probability of not selecting a composite. So if we're not selecting a composite, we're selecting a prime. All right. Now, I need everybody to write this down. What is the first prime number? What's the first prime number? Yeah, everybody says what? 1. But everybody is what? Wrong. All right. It is what? 2. All right. 0 is not a prime because 0 times anything is always 0. So 0 is out. 1 is a unique number. 1 is not prime because the definition of prime is that you have 2 factors. That's it. 1 and itself. The number 1 only has what? 1 factor. Just 1. All right. So 1 is not a prime. So is it composite? No, it doesn't fit that definition of composite either. Composite is it has more than 2 factors. All right, composite means it has more than 2 factors. All right, so the reason why I'm telling you this again is because sometimes when you take ERB questions, this would be what? Easy if you remember prime and composite. And especially the number 1 is on a lot of standardized tests because they know kids don't remember the definition of prime. Must be how many? 2 factors to be prime. The only factor of 1 is 1. All right, there is no other factor. All right, so if I said, for example, 9 has how many factors? 3. 1, 9, and what? 3. All right, you may have any questions. All right, so here, a number is chosen. So I want to know if it's prime. So is 1 prime? No, so the first prime is what? And the only even prime number is what? 2. Every other even number is a what? Composite number. So now after you get to 2, we just do the odds. All right? Yes. I already told you why it's not 1. Oh, you are smart. Thank you. Very smart. I appreciate that, really. I wasn't even thinking. That's very, very good. All right. If it's not, we don't want a what? Composite. Is 1 composite? No. So I did make a mistake. Thank you. All right. So definitely 1 is there. I appreciate that very much. All right. Because I definitely would have made that mistake. And that is a fantastic ERB question because, again, people like me who understand math just made a what? Careless mistake because we didn't read carefully. This is what I'm trying to tell you about improving your ERBs. It's not going to be about you're smarter in math. It's going to be can you read carefully? All right, and not just automatically write down something because you think you're right. You got to think through it. All right, you got to think through it. All right, so again, that's a good job. All right, now I want the prime numbers. What's next? What's next? What's next?
3.
Oh, help me out, guys, here. 3. Now, am I doing any evens? No. So then 5, yes or no?
Yes.
7,
Yes.
9,
No.
11,
Yes.
13,
Yes.
15,
No.
17,
Yes.
19,
Yes.
okay, 21,
No.
23.
Yes.
All right. What's that? What do you mean? Shh, no, leave him alone. What's a prime number? Do you know what a prime number is? Prime numbers only have two factors. All those only have two factors, one in itself. Why wasn't 21 prime? Why isn't 21 prime? Yeah, there you go. That's it. That's all there is. All right. Why was, what else? 15. 15 is not prime because 5 and 3. That's it. That's all there is. All right. So now, count those up for me. Is that right? 10 out of how many? 10 out of 25. So we reduce that down to what? What? What does that reduce to? Somebody. 2/5. What? Yeah, but I don't want it as a percentage, remember? I want it as a fraction. I want it as a fraction. Is everybody okay with that? All right, so here we go. Hey, you're interrupting. All right. So, a number is chosen at random from 1 to 25. Find the probability of selecting an even number or a multiple of 3. So here's how I want you to handle this, guys. I want everybody to write down from 1 to 12, all the numbers. 1, 2, 3, 4, 5. Don't be lazy. Find the probability of selecting an even number. All right, so after you wrote all of them down, I just want you to circle all of the even numbers. Just circle all the even numbers. Or a multiple of 3. All right, so now what are the multiples of 3? 3, 6, 9, 12. Those are all the multiples of 3. Is everybody with me on that? So now what I'm going to do is I'm going to circle the multiples of 3. Now the problem with circling the multiples of 3 is some of them are also what? Some of them are also even. All right, because we've circled all the evens. Now what we're going to do is we're going to count the multiples of 3. 3, 6, 9, 12, 15, 18, 21, and 24. All right, those are the multiples of 3. All right, so again, how many did we select there? Now you got to go back and count them up. Somebody count them up. Somebody said we got how many?
16.
Somebody said 16. I'm not sure. I'm not saying he's correct. Does everybody agree? 16? 16 out of how much? So you have a 16 out of 25 chance. Is everybody with me on this? All right. Girls, you all right back there? Everybody's right? It's very simple. That's why I'm going slow now. I want to make sure you're with me on the counting part of it. All right, here we go. Now, a number is chosen at random from 1 to 50. Find the probability of selecting the prime numbers. All right, so this is kind of annoying, but I really want you to list out 1 through 50. No, because all we really need to do is count the what? Odds, right? So you got to stay with me now. All right. I know, but not all the odds, but none of the evens, except what?
2.
Except 2. Can we start with 1?
No.
No, we do not. So the first prime number we're going to talk about is what? 2. And then what about 3? Now, all I want is a yes or no. All right? That's all I want. So if everybody tries to give me something, everybody agree it'll be annoying. All right, I want you to think about it. I'm trying to show you how in my mind I'm counting out the prime. All right, I knew 2 was prime. I knew 1 was not. Now I'm looking at 3. Is 3 prime? 5, 7, 9, 11, 13, 15, 17, 19, 21, 23, 25, 27, 29, 31, 33, 35, 37. Here's one that people miss. 39. 13 times 3, so 39 is not. 41, 43, 45, 47, 49. All right, so those are the primes. All right, those are the primes. And I promise you I'm going to ask you that on the test. All right, you're expected to be able to kind of go through just the way I did it. All right, you're expected at this age to know what a prime, what a composite is. All right, so now I need some help. How many is that?
16.
So you guys got to count them up now. I can't have 3 people tell me 3 different answers. 15. So 15 out of what? Which is the same as 3 out of 10. All right. Everybody okay with that? What? Stop mumbling under your breath and tell me something you don't know. It's rude to just sit there and mumble under your breath and complain. All right, let's count 16. I could be wrong because I took your word. All right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. It doesn't matter. It doesn't matter. Come on. Just face the front. It doesn't matter. That's the problem with some of you. All right, it's not like you haven't made a mistake before. All right, here we go. All right, now go to the next one. Watch, plug in, make sure we don't lose power here. All right, so next problem. All right, next problem we have. A number is chosen from 1 to 25. Find the probability of selecting an even number that is greater than 13. So on an even number greater than 13, so I probably should start at what? 14. So then everybody should write down 14. Hold on a second. 14, and then what?
16.
And then what?
18.
I'm going.
20, 22.
All right.
6 times 25.
So 6 out of 25. Okay, you okay now? Seriously, I'm trying to help you. Okay. So now you do, right? All right. Here we go. 6 out of 25. All right. Now, in the interest of time, this is what I think I want you to try on your own tonight. See if you can answer 6, 7, 8, 9, and 10. All right, just try to answer 6, 7, 8, 9, and 10. If I have more time, I'm going to come back and do it. All right, but I want to move ahead. We've got a shorter class today. All right, so now I need you to write the sample space of rolling 2 dice. All right, now I wrote this up here just because I think this is a nice way of doing it. All right, so here, in this column right here, you can just put an X on there if you want. All right, just put an X there. All right, and some of you already know how to do this, so if you don't want to use this, that's okay too. All right, on the top, you can roll a what? You can roll the numbers 1 through 6. All right, going down, you can roll what? 1 through 6. All right, so this was helpful for me when I was doing it. All right, so in the first box, you're going to have a what? 1, 1. The second box, 1, 2, 1, 3, 1, 4, 1, 5, and 1, 6. Are you okay with that? And then the next one is going to be what? 2, 1, 2, 2. Yes, sir.
The way I did it was I just had
I'm totally fine with whatever you have. I just want you to be able to tell me the numbers. That's all. People do different things. I just thought this was a pretty nice way to do it. All right. You can also just write down 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 2, 1, 2, 2, 3, 3. I mean, it's the same thing. But I just like it like this. All right. And so on. All right. This would be 2, 2, 2, 3, 2, 4, 2, 5, and 2, 6. 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6, 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6, 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6, and then what? 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6. All right. Now, I want to show you this right here. These, when you throw the dice, are the only options. Do you agree? But a lot of my kids didn't understand when I said, how many options are there when you throw the dice? How many options? There are 36, right? But yes, because the fundamental counting principle says you have 6 options, 6 options, 6 times 6 is 36. But most people don't understand throwing dice because you can only get, if you add them up, numbers from what?
1 to 12. Or 2
2 to
to 12.
12. You can only get numbers from 2 to 12. So most people don't understand there are 36 different possibilities. So what I want you to take a look at right now is, please watch, what's the sum of this first one right here? 2. Now watch me, please. This is how I want you to think about it. From here to here is what? What's the sum? 3. And the sum from here. So the sum is always on the diagonal. The sum is always on the diagonal. Everybody see what I'm getting at? All right. Now, hold up, and just watch. Watch what I'm trying to show you. This brown is all the what? 6s. And then we have this down here, which is all the what? 7s. And then this down here is all the what? 8s. And this down here is all the what? 9s. And then the next one is the 10s. And then the what? 11. And then finally what? 12. So you see, most people didn't really understand that. All right, most people don't understand that. So you can have numbers between what? 2 and 12. So now why do you think when you throw the dice they call it lucky 7? Because 7 occurs what? The most. But does it occur the most when you take into consideration all the other numbers? No. So that's why people bet on 7, thinking that's the best way, right? It's not. All right? You can get a 7 more ways. All right? How many ways can you get a 7? 6. All right? So here's what I want you to try to remember. A 2 can occur how many times? Once. A 3 occurs what? A 4 occurs 5, 6, 7. Now watch. Here's the problem. Once you get to 7, the next number is 8, which is back down to what? 5, 7. I'm sorry, not 7, but 9. And then 10, 11, and 12. Now what happens, guys, if I were to take these numbers right here and add them up? What would that add up to? What would it add up to? 36. Thank you for listening. It would add up to 36. So again, I'm really trying to show you how you can now understand, all right, what they're talking about when you throw 2 dice. All right? Those are the chances that you land or you get snake eyes, which is 1 and 1. All right? Boxcars is called what? 6 and 6. All right? So you have 1 out of 36 chance of getting a 2. You have 1 out of 36 chance of getting a 12. You have what? 6 out of 36 to get a what? To get a 7. All right, is everybody with me on that? If I said what's probably getting a 3, you would tell me it's 2 out of 36. 4 is what? 3 out of 36, and so on and so forth. All right, that is critical for you to understand the next page. All right, that's critical for you to understand the next page. What? I just counted them up.
I know.
And then I discovered a pattern. 1, 2, 3, 4, 5, 6, 5, 4, 3, 2, 1. It's that simple. All right, you get a 2, a 3, a 4, 5, 6, 7, 8, 9, 10, 11, 12. Then it starts 1, 2, 3, 4, 5, 6, 5, 4, 3, 2, 1. You got to write it a couple times. Then you'll be able to see it. If you can see that, then the next problems become much easier. So let's look at this guy. Find the probability of rolling factors of 6 on both dice. So this is kind of annoying. So factors of 6 on both dice. What are the factors of 6? Let's review that. What will be the factors of 6?
2.
There's one before that. 1. Then a what?
2.
2. Then a what? 3. Yeah, 1, 2, 3, 6, right? So instead of counting 1, 2, 3, and 6, it might be easier just to count what? The ones with just what? They both. It says here, find the probability of rolling factors of 6 on both dice. All right. So what I want to do now is I want to come back up here, please. All right. Now, everybody, take a look at what I'm trying to do here. And now on yours, you can kind of count these out. All right. And I'm not going to lie. This is kind of annoying. All right. But it has to have a what? A 1, 2, 3, 6 on both dice. So does the first one work out? Yes. Does this one work out? Yes. What about the next one going down? No. What about number 5? No. And here you go. You see that? And then we do here, yes, 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 no. Yeah. Does everybody agree with that? What? I'm looking for the factors of 6 on both dice. The factors of 6 have to be on both dice. The factors of 6 have to be on both dice. So now I'm looking here. Does that work? Does this work? Is 2 in? Does that work? Does the next one? Does the next one? Yes. Right. Now, what about anything with a 4? No. So sometimes it's easier for me to just come up here and say, this is out. Right? And anything with the 5 is out. Anything with a 4 is out. And anything with a what? 5 is out. So everything else works. Does everybody agree with that? All right. So we can now just kind of count. Not that one.
16.
How many? Let's count.
16.
16 out of what? 16 out of 36. 16 out of 36 is not 50%. 16 out of 36, if I reduce by 4, that would be 4 out of what? 9. Almost 50%. You're right. Almost 50. What? All right. Now again, notice what I'm doing. I'm going back and forth to look at my table to answer the question. All right, that's what I'm doing. That's what you need to be doing. All right? So now the next one. Find the probability of not rolling a 7. So how many 7s were there again? 6. Some of you remember. If not, you just count them. There were 6. So if you don't want a 7, that's why I'm saying it's not really lucky, because how many of them are not? 30. There's 36 altogether, right? So it's not lucky 30 times out of what? 36. And if we reduce that, 5 out of 6. All right? Now you want to find the probability of not rolling the difference of 1. So when you throw the dice, you want it to have a difference of what? 1. All right, so let's go back. Let's look at now what I'm saying. So here we go. This will take me a second. All right, so to me, the easiest way to do this would be to look at my answers, and it would be for me to look at them and say, this does have a difference of 1. Does everybody agree with that? All right, and you can see the patterns now. If you have a difference of 1, does that have a difference of 1? You agree? Right? And then, what else? 3, 2, and 2, 3, right? Then, what else? 3, 4, and 4, 3.
5, 4, 4, 5.
6, 5.
6, 5, 5, 2.
There you go, guys. That's the only options. So how many are there?
10.
There are 10. So now we look back and say there are 10 that do have a difference of 1. So that means what? 26 out of 36 what? 26 out of 36 what? Do not. All right, which makes it, thank you, 13 out of 18. So what's the probability of rolling the same number on each dice? That should be easy for us. 6, right? 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, right? So that would be 6 out of 36, which is gonna, so it's gonna occur 1/6 of the time. Yeah, don't worry about the test. I'm taking care of you. Don't worry about it. All right, I think this is hard. All right, so you just gotta, that's why you have to work with me. You have to try to answer the question. Again, I keep trying to tell you guys, if all you're doing is writing down my answers, you're making a big mistake. You should be able to tell me now, we're trying, what's the next one?
Not rolling a sum of 10.
The probability of not rolling a 10. So let's count the ones that are 10s. How many of them are 10s? Does everybody agree there are 3? If you're not sure, look at and there's 6 and 4, 5 and 5, 4 and 6. So there's 3 out of 36 that are 10s, which makes what? 33 out of 36, which are not, which reduces to what? 11 out of 12. 11 out of 12. All right. So here's what I want you to do. 16, 17, 18, 19, 20. Try to answer those questions. All right. Now let's flip the page. Let's see if there's anything harder. I don't think there is. All right. Here we go. So you're spinning this spinner. Do you have an equal chance of landing on either A or C?
Yes.
Is there one A and one C? So you have a what? Equal chance. So we would say yes. What's the probability of landing on E?
1 out of 6.
How many?
1 out of 3.
Yeah, but let's go with what
1 out of
first?
3.
2 out of 6,
1 out of 3.
and then reduce it to 1 out of 3. What's the probability of the spinner landing on A or E?
1 out of 6.
Let's do, guys, I appreciate you guys telling me the answer, but I prefer that you tell me there are what? 3 out of what? 6. All right, really, that's the important part. 3, 6 reduces to what? 1/2. All right, what's the probability not landing on C?
5
out of 6. Okay, now do me a favor. Let's just highlight 25, 26, 27. All right, what's the probability of the spinner not landing on 2? So we got to figure out how many 2s there are. How many 2s are there? Okay, so then how many numbers? 12. What's the probability of not landing on 2? 11 out of 12. What's the probability of not landing on a 2 or a 3?
There's 7.
Well, I'm going to find the 2s and the 3s, right? Wow. So there we go, right? So I don't want a 2 or a 3, right?
5 out of 12.
Is everybody okay with 5 out of 12? Everybody happy with that? All right. Now, hopefully I didn't annoy some of you with just if you've forgotten some things. I'm not going to, this is what I'm telling you about the ERBs. They're going to ask you probability questions, and if you forget those basic terms, you're not going to know how to answer the questions. That's why we're reviewing. All right? So hear me out, guys. Do I think it's necessary to do the IXL?
Yes.
No. You don't have to do IXL. All right? Well, we're not going to do it tomorrow probably, but we're going to probably do it on one of the days this week. All right? So I wasn't sure how much time it would take me. But your job tonight, when you come to class tomorrow, I'm going to go around the room. I'm going to say, what'd you get, what'd you get, what'd you get, what'd you get? I want you to give it a good shot. If you don't know how to do it, come see me in the morning. All right? But hopefully you have a good job. Hopefully you got a better feeling about simple probability. Called simple probability. All right, good job. No IXL. No IXL. Just finish the worksheets. You do need it. I'm not arguing with you. Get to work. Go ahead. What?